Hello my fellow working class heroes, good day. I am Carlo and welcome to Carlo Excels. These are the objectives of this episode. We're gonna talk about the average function definition, and then we're gonna talk about the applications of the average function, and then the average function versus basic calculations. Afterwards, we're gonna talk about the average A function definition, and then the applications of the average A function, and of course, we're gonna compare the average A function versus the average function. Let's start with the definition of the average function. Now what you can see on the screen is from Microsoft's own help documents. Average function returns the average or arithmetic mean of the arguments. It is the sum of a collection of numbers divided by the count of elements. Blanks and text are not included in the count of elements. To call out the function in a formula, the function name is average, and of course your function arguments are values. Here we are in our Microsoft Excel screen, so we have our students here and we have here their scores in 10 quizzes. Don't worry, the fact that they all have the exact same scores for all of their quizzes is on purpose so that we can compare the results of their averages based on different methods of calculation. If you've been following our lesson so far, and by the way, if you have been following our lesson so far, thank you very much for supporting the channel. So if you've been following the lesson so far, you might have noticed that we already so far have 3 methods of calculating averages. We first have the basic calculations method, and then the sum divided by elements method, and then we have what we're trying to teach now, the average function method. As a review, let's try the basic calculation method first. So let's do a basic calculation of this. What we do is place the equal sign, parenthesis, then we add all of these quiz scores together with a close parenthesis and divide all of that by the number of elements, in other words 10, and we have 6.3. On our previous lesson, we already learned the sum function and we can apply it here. So what we can do is equal sign and then declare the sum function like so, and then we set this range over here, and then this divided by the number of elements, which is 10, and we have also 6.3. And of course, we can copy all of this and then paste it all of here so that we have 6.3 on all of these rows. Now let's try the average function. We already learned from a previous lesson that the average function does in fact work for constants. And when using it with cell references, this is the first way that you can use it. So we declare the function name, which is average, open parenthesis, and then you can select the cell references one by one, separated with a comma. So you can do it like this, just like doing a basic calculation. And what Microsoft Excel will do, of course, is to average all of those selected cell references together, press enter, and then you get 6.3. Second, the average function also works with ranges. So what you can do is declare again the average, the function name, like so, and then you can simply drag your mouse here to declare the range, and you have the exact same result. And of course, the average function can in fact work with multiple ranges, so you can do it like so. So average, then you can declare this range over here, separate by a comma, and then declare this range over here, and then close parenthesis, and you have the exact same result. It works that way as well. And just like what we discussed previously, yes, the average function can in fact be nested, meaning an average function can be an argument within another average function. So we can do it this way. So we declare the average function like so, and then open parenthesis, and then take note the average function is going to be an argument within an average function like this. So we declare this range over here, and then the next argument is gonna be another average function like so, and then press enter, and you have the exact same result. And of course, the average function, just like any other function, works with copy-paste as well. So we can copy and paste all of that, and there you go. So let's talk a little bit about the average function. If you are a teacher, especially here in the Philippines, and your school is closely following the grading system of the Department of Education, you will notice that you don't actually average the scores. In fact, you sum all of the scores. But there are in fact some schools who do not closely follow the grading system of the Department of Education. So therefore, when it comes to the grading of quizzes, they don't in fact add all of the scores together. What they do is they average the scores. And if you belong to one such school that averages the scores, please listen to this next part carefully. Any teacher, I think, can relate to what I'm gonna say next. This isn't what our usual grade book looks like. It's very rare for us to have a quarter and then have a grade book with all of the students being able to take all of the quizzes. Our grade book does not look like this. In fact, it looks more or less like this. So you have your blanks, you have your zeros, and in some cases, you have your absences. For teachers in their grade books, whenever a student takes a particular quiz or takes a particular PT, but it just so happens that the student scores 0 on a quiz or a test or a PT that he or she took, we usually actually write 0 on the grade book. But when it comes to absences or non-compliance of work, teachers treat that differently when it comes to their grade books. For some teachers, they treat absences as blanks, complete blanks, blank cells on their grade books. And for some teachers, they actually put in some sort of character to signify an absence. For example, some teachers write the letter A as an absence. So what are we gonna do next? What we're gonna do is we're gonna take the average function, basic calculations, and then we're gonna take the sum function divided by the elements, and we're gonna compare them, and then we're gonna see what they do with blanks, what they do with zeros, and what they do with absences, or in other words, text in the cells. So for the first row with the blank, let's try the average function first, like so. And then let's try the basic calculation next, like so. So all of that divided by 10. And then let's try the sum function divided by the number of elements. So sum all of that divided by the number of quizzes, 10. You will now notice that they have different results. Why is that? Please remember that in the definition of the average function, please remember that the average function ignores blanks. In this situation, what the basic calculation formula and what the sum function divided by the number of elements does in this case is this. It's going to add all of these elements together and then count the blanks as zeros. So they're gonna add all of these and then divide it by the number of elements, which is 10. So you will notice that there are 8 5s here, and then there are 2 zeros. So 8 times 5, that's 40, divided by the number of elements, that's 10. So that's why the answer is 4. But for the average function does not even notice or recognize or even acknowledge the blanks. So what the average function does is, it will only look at the cells that actually have value in it. So as far as the average function is concerned, there are only 8 elements and all of them have 5 in it. So therefore, the average for the average function is 5. So in this situation, the calculations that are actually correct are the basic calculation and the sum divided by elements. Now let's try this second row. Now this second row no longer has blanks in it, but this time they actually have zeros in them. So let's try averaging them using the various methods. Of course, in this case, we don't have to write the formulas again. We can just copy these and then, of course, paste formulas. Now, in this case, you will notice that they now have the exact same results. Of course, nothing has changed with how basic calculations and how the sum function divided by elements treats these values. But what changes now is how the average function treats these values. Now, the average function actually sees and recognizes the zeros. So the average function now includes this in the calculation, in other words, in the sum, and then it also includes them in the number of elements. So the average function now sees the zeros, adds all of these together, and divides this by the number of elements, which is 10. That is why the answer is 4. So in this case, all 3 of them are now correct in this situation. And what about this method wherein we connote absences by writing the letter A or writing text or something? So let's try this. Again, we don't repeat the writing of the calculation or the formula. What we do is we copy this and paste formula. And that is your result. Let's try explaining the results first. For the basic calculations, please remember that basic calculations cannot calculate text. So therefore, as far as the basic calculations is concerned, it sees these letters, these text data, and cannot calculate them. That is why it returns a value error. For the sum divided by elements, please remember that we said in a previous lesson that the sum function ignores text. Alright? So as far as the sum function is concerned, these 2 A's over here does not exist. So what the sum function is going to do is, it is simply going to add all of the 5's together, ignoring the A's. So the result is still 40 divided by the number of elements, and the answer is 4. And for the average function ignores text. In other words, as if these were blanks. The average function will not recognize these, will not include them in the count of the elements. So as far as the average function is concerned, you only have 8 5s in this row. So that is why you have 40 divided by 8. That is why the result is 5. So in this situation, which one gives you the correct result? Well, the one that gives you the correct result is the sum function divided by elements. The 4th, 5th, and 6th rows will have the exact same result as with the first, the second, and the third results. So if we copy this and then paste formula here, you will notice that you have the exact same trend. For the 4th row, only the basic calculations and the sum divided by elements are correct because again, the average function does not even recognize these blanks here. For the 5th row, all of them will be correct because in this case, the average function now of course recognizes these zeros. And for the 6th row, only the sum divided by the number of elements will be correct because again, the average function does not recognize these text data. And on the 7th, 8th, 9th, and 10th rows, you will now see that there are combinations of blanks, text, and zero data. So if we take these formulas here and copy formulas over here, naturally, the only one that is consistently correct will be the sum divided by the number of elements. So what am I trying to say? Am I trying to say that the average function is going to be useless? No, I'm not saying that the average function is useless. I am just saying that be careful when you use it because the average function only functions well if you're not going to count the blanks and if there is no text data. Because if there are blanks and you want to count them and if there is text data, then the average function will not work for you. And of course, when it comes to calculating test scores, as you now see here, the average function does not work very well. That is why in some situations, you may not want to use the average function, but instead, you may want to use the AVERAGEA function. So what is the AVERAGEA function? Again, this definition comes from Microsoft's own help document. Average function returns the average or the arithmetic mean of the arguments. It is the sum of a collection of numbers divided by the count of the elements. Blanks are not included in the count of elements, but text are included. To call out the AVERAGEA function, you have to enter the function name. In this case, it is AVERAGEA, and the function arguments are values. So we're back here in this screen, and instead of using the average function, this time we're gonna use the AVERAGEA function. First of all, the AVERAGEA function works almost the exact same way as the average function. So just like the average function, the AVERAGEA function works for single arguments, like so, separated by commas, like so. Just like the average function, the AVERAGEA function also works with ranges, like this. And yes, just like the average function, the AVERAGEA function works with multiple ranges, like this. So let's see how the AVERAGEA function stacks up with the previous methods already discussed. For blanks, let's try the AVERAGEA function, like so. Select this range over here, and you will see that the answer for the AVERAGEA function is also 5. Why? Because the AVERAGEA function, just like the average function, ignores blanks. Now let's try the AVERAGEA functions with zeros in this second row. So if we have zeros, the AVERAGEA function, just like the average function and all other methods, looks at zeros and then counts them accordingly. That is why the answer is the same as all the others. Now let's try text data. As for text data, the answer of AVERAGEA, again, instead of having to repeat doing the formula, we just Control C and then paste over here, you will notice now that the answer is 4, just like sum divided by number of elements. And why is that so? Please take note of what the AVERAGEA does with text. The AVERAGEA does not count the text when it comes to the addition part of averaging. It does not look at the text. It does not add the text, right? But when it comes to the counting of elements, the AVERAGEA does in fact count the text data. So what AVERAGEA is going to do here is 5 plus 5 plus 5 plus, oops, text data, gonna ignore that, plus 5 plus 5 plus 5, another text data, gonna ignore that, plus 5 is equal to 40. And then when it counts the number of elements, 1, 2, 3, 4, it will count the A, 5, 6, 7, 8, it will count the text data, 9, 10. So that's 40 divided by 10 is equal to 4. That is why the result of the AVERAGEA is just like the sum divided by the number of elements. And of course, you will get the same result with the 4th, 5th, and 6th column. So copy here, paste there. You will notice that, again, it will not count the blanks. That is why when it comes to blanks, the average A function does not return the correct results of averaging the grades. When you have zeros, the average A does do well. But when it comes to also text data, the average A function also does well. And as for the last 4 columns here, let's look at what the average A does. In this case, the average A fails in this row because there are blanks. And again, the average A function does not look at blanks when doing the averaging. There are still blanks here, so therefore the average A function does not work well as well here. Now, in this case, there is still a blank, so that is why the average A is still not doing well. But in this last scenario, in this last row, because there are no more blanks, the average A now counts all of these elements as 10, and so therefore, you now have a correct result, which is 6. So to summarize the difference between the average and the average A function, both functions are for averaging. Both functions do not count blanks, but the average function does not count text. The average A function does count text in its number of elements. Now, my dear viewers, I do not want you to think that the average function and the average A functions are useless, they are inaccurate, so therefore you're gonna stick with the basic calculations. Actually, the average and the average A functions are very, very useful. First of all, because they can use ranges. So in fact, you can use the average or average A functions to average like hundreds or thousands of numbers instantly. Something that you cannot do with basic calculations. And the beautiful thing about the average and average A functions using ranges it's because ranges have its own advantages. Now, the advantages of ranges and the full lesson on ranges will come at a later episode. So once again, please subscribe to the channel so that you won't miss that lesson when it comes. So when should you be using the average and the average A functions? The average and average A functions work well when you are certain about what you are averaging and you need it to have a variable number of elements, meaning even you are not sure as to how many elements you are averaging in the first place. That is when the average function and the average A function work well. But as you can see here, the average and the average A functions do not work well with test scores. So for those teachers who belong to schools that use averaging in their calculation instead of just the sum, I suggest the sum divided by the number of elements method when it comes to averaging test scores and results. But there is in fact a better way of doing it, and that is by using either a combination of the sum function and the counting functions. When I say the counting functions, we're talking about count, count A, count blank, and count if, those functions, or you can use the average if function. The counting functions and the average if functions are lessons for a later time. So once again, please subscribe to the channel so that you won't miss those lessons when they come. So that's it for this lesson on the average and the average A functions. Once again, I am Carlo. This is Carlo Excels. Thank you very much for watching.